and welcome to a recorded version of the Industry 4.0 Community Podcast, sponsored by 4.0 Solutions. I am your host with the most, Walker D. Reynolds. Today, our guest is Alex Klein, and we actually will have Justin Dula with us. Alex is with Intellic Integration, and Justin is with 4.0 Solutions. He works with me. We are going to have a conversation about artificial intelligence and machine learning. But before we get started, I'm going to go ahead and have Alex introduce himself to the community. Alex, welcome. Why don't you tell us a little bit about yourself, bud?
Yeah, thanks for having me on. First time I've done this. I've done the mentorship a couple of times, so some of you might recognize me from there as the Docker guy. But me personally, I've been in industrial automation for almost 10 years. I actually started turning a screwdriver, and I've slowly worked my way away from the plant floor, and now I spend most of my time in the cloud playing with containers and specializing in the world of kind of data transfer, producing and consume and so on.
What is your educational background?
So I have a bachelor's degree in mechatronics engineering from CSU Pueblo. It's a little school here in Colorado. I'm based out of Castle Rock, Colorado. And they have a very strong mechatronics program that, robots are fun. So I figured I'd give that a shot, and here I am.
So as Alex mentioned that, those of you in the community who are in mentorship, you might recognize Alex because he's taught a couple of the mentorship sessions specifically centered around Docker and Docker Compose. And hey, actually, Justin just jumped in here with us. So Justin, we are doing a podcast on artificial intelligence, machine learning, and you as the resident data scientist at 4.0 Solutions will be our technical resource. But why don't you go ahead and introduce yourself to the audience, who you are, how long you've been here, and what's your background?
I joined Intellic about a bit more than 90 days ago. I was supposed to have my 90-day review like a week or two ago, but it kept getting rescheduled. So I came from a AI and machine learning background at the University of Texas at Dallas. This is my first job out of academia. I've got a master's degree, and I was an RA for a while. Then I decided to move into industry when I saw how sort of the economy was shaping up. So I've joined a couple months ago, and I've been enjoying it so far.
Excellent. So real quick, Alex. So Alex went to University of Colorado at Pueblo. Here's everything I know about Pueblo. There is a Tesla charger in Pueblo, Colorado. It is actually the only Tesla charger I've ever come across that's in a parking garage. So it's in a parking garage, like you can't find it. It's literally like 9 chargers on the slope of a parking garage, and it's not next to anything. So most Tesla superchargers are like at a gas station or at a Buc-ee's, or you could do something while you're charging. You can't do anything. It's like there's like a bank next door. There's like the nearest thing's like a mile away. So all you have are like people charging their Teslas and just sort of walking around the parking garage while they're charging, because there's nothing. I think there's like a convention center across the street or something. But that's everything I know about Pueblo. Also, Alex, you played football, right? Did you play football in college, or did you play just in high school?
Just high school. I coached high school football while I was in college.
Okay. And so Alex is sort of our, Alex enjoys education and teaching as much as I do. And so we've really been leaning on Alex to support us with in our educational efforts at IIoT.University. And also, Justin, you work at Intellic. You don't work at 4.0 Solutions?
It's kind of both.
Okay. I mean, my
employment contract is with Intellic.
Okay. So, good. All right. Yeah. All right. I didn't. I thought you worked at 4.0 Solutions.
No.
All right. So let's talk about where this conversation came from. So about a month ago, I actually don't remember. I don't remember what prompted this, like what was going on externally that prompted the conversation. But Alex reached out to me via Teams and I'm just going to go ahead and read like what he sent to me. And he said, it seems like every maker of software or services says that we have AI. Really leaning into AI as a buzzword. My question and a topic of a possible podcast would be, how do I sort through the nonsense to find the true implementations and value versus a company that is just using AI as a buzzword to drive sales? And he said, I got this today from Tableau, and this is why it's on my mind. And there was it looks like it was a sales thing, and it said, act fast to save $400 on Dreamforce. Do more with AI. Learn how at Dreamforce, the AI event of the year. See the latest AI plus data innovations and act now. And then there was a registration thing for $400. And he said, it feels almost as though the actual usefulness of AI is getting diluted by its overuse as a sales tactic. And he wanted to know, what do you think about that? Should we talk about it? And we started. He wanted to know what questions should we ask so we can weed through it. And we said, why don't we fucking do it in a podcast? And so that's what we're doing. So I actually want to start with this, and we have not prepped Justin at all for this podcast whatsoever. I mean, Alex and I had 5 minutes to prep, and we had a conversation. We literally sent a message to Justin on Teams and said, join this podcast as soon as you're available. And so we're going to start with this, Justin. So let's start with the definitions, okay? Let's define what machine learning is, and let's define what AI is, and let's do it from the perspective of a data scientist or someone who studied computer science and specifically machine learning and artificial intelligence. Would you care to define machine learning and artificial intelligence separately for our audience?
Okay, so first thing I'm going to say is there's not like one definition. You'll see different definitions in academia. You'll see different definitions in different subsets of academia in fields of industry. But I think a suitable high-level definition is AI is anything you use that is somehow analyzing the data in a way that allows you to either extract value or make decisions from it.
Automatically?
Not necessarily.
Okay.
I would say it could be something. A simple AI system might only be presenting data to a human, and that human still makes the decision. This is often necessary in some systems. So like in medical context, you have to have a doctor eyes on and making decisions.
Okay.
And there's like legal and liability reasons, and there's also just like safety reasons. So it depends on the field. So you could argue that like logistic regression is a simple, perhaps this prototypical AI, if you will.
Give us an analogy for the non-technical person. Give us an analogy that would help illustrate to a non-technical person what logistical regression is.
So let's say I'm throwing a ball, and I am not really sure how strong I am, right? But I can say, okay, that kind of felt like I was throwing at 50% and it went there. And this time I felt like I was throwing at 70% and it went even further. And this time I felt like I was throwing at 80% and it went even further. I look at those points, I say, well, I've got 50, 70, 80%. The ball went this far, this far, this far. How far do I think it'll go at 100%? I don't know if this is showing up on camera. This far.
It is. Yep.
All it's saying is we're looking for basically a best fit, a way to predict our data. And usually with logistic regression, we're looking for a relatively simple fit. Most of the time, with a lot of machine learning tasks are essentially this data is too complicated. The underlying function is too complicated for me to just throw a line at it. I need something it's a much more complex function. It's not a linear relationship. It's maybe not even a polynomial relationship, but it can be a very, very sophisticated relationship that we might capture with something like a large decision tree, a neural network. Deep neural networks can provably capture any function past a certain depth. That doesn't mean they will capture anything, but it is mathematically possible.
Right.
So is that where it crosses the line from machine learning to artificial intelligence?
I would say machine learning is more the case where you've got this system and you have the ability to improve it by giving it data.
Mm-hmm.
So the classic example would be like in that ball problem, maybe if I just say, all right, I look at this and I say, oh, my function is I throw it 3 meters for every percent of strength. Okay, that would actually be insane. I throw it like 3 inches for every 1% of my strength that I use. But with machine learning, that would be like, okay, I give it a bunch of predictions. I tell it what percent of my strength I used, what I feel like I used, and it slowly improves its ability to predict.
If you were to delineate the difference, okay,
machine learning is data driven.
Yep. So machine learning is data driven. Artificial intelligence is
a superset. So I would say all or almost all machine learning will fall under the umbrella of artificial intelligence.
Correct. It's a subset
but not all artificial intelligence is necessarily data driven. It might be like a lot of sort of classic, like a video game AI or a chess AI.
Mm-hmm.
It's using rules that are coded by experts, but there's no actual learning of those rules being done by a machine. Those are done by, centuries of chess expertise, grandmasters writing down what they understand about the game, but there's no self-play happening to learn the rules. So that's where we see things like, so a lot of sort of the original chess engines were basically just rule engines. And then the explosion when we started seeing really, really powerful chess engines to now we're at the point where they're unbeatable. There's no human good enough to beat the best chess engines. It's not possible.
What's the difference between a rules engine and a decision tree?
A rules engine, so a decision tree works typically off of binary decisions. Theoretically, any rule engine could be expressed as a binary tree. It just might not be necessarily efficient. But generally speaking, the other thing about decision trees is they're generally learned. You can learn rules. That is, it's a whole subfield of machine learning, but it is not necessarily. Not all rule engines are learned. Almost all decision trees will be learned, because oftentimes for human. Okay, I guess I should actually take a step back and define what decision tree is. So a decision tree is basically I just ask a series of questions that I learn, and I learn what questions to ask to give a prediction. So maybe I'm trying to predict how long it is since Alex last shaved, right? Shaved his beard. So maybe my first node would be how long is his beard? Or maybe it would be the day of the week. I don't know what his schedule is.
It's when my wife tells me I look homeless.
Okay, so maybe my first decision is how his wife is feeling on that given day. And my second might be if his wife is feeling good, then I just check how long his beard is. If his wife is feeling bad and wants to take out some anger and tell me he looks homeless, then maybe I check how long is it. I check how long it's been since he's shaved or what day of the week it is. But basically, I learn what decisions to make, and I create this tree. So I have a node where I ask my first question. Then I have two children there, yes or no to my first question. And you could theoretically have a larger branching factor, but in practice, 2 is usually good, yes or no. Until eventually I reach some stopping condition and I say, all right, I think Alex needs to shave, or I think Alex is good.
What I like to say when someone asks me about a decision tree, I say, are you familiar with a mind map? And if they say yes, I say a decision tree is a lot like a mind map, except it's simpler. It's only binary decisions. So that's the way I try to explain it. When people ask me what is artificial intelligence, I say artificial intelligence is just basically computers trying to mimic human intelligence, and machine learning is using computers to learn from data. That's what I always say. I say that's the fundamental difference. Like machine learning is all about learning from data and then trying to take what I learned and predict something, whereas artificial intelligence is trying to use computers to mimic what humans do in general. That's what I try to say. All right, so are we good if we use those two basic definitions of machine learning is basically learning from data, and artificial intelligence is trying to mimic human intelligence?
I don't know if I agree with the trying to mimic. It's a valid definition. I don't think it's the best definition.
Okay,
but I think
uses our best definition.
I would think it is. I think to understand what a better definition is requires to understand that mimicking human intelligence isn't always the goal. There are some fields where we can be a lot smarter than humans or make decisions in a manner that is fundamentally different from how humans think.
I was going to bring that up later, which was, well, this famous statement that Elon Musk made. He said the biggest mistake that smart engineers make is that they try to optimize a solution that should have never existed in the first place, right? And if artificial intelligence's goal is to only mimic human intelligence, well, then you're limiting artificial intelligence to what it is humans can achieve, right? That would be the problem. The problem with it, like, for example, artificial intelligence at scale can do many more computations than human intelligence would ever be able to achieve. That's the reason why chess engines are the chess engines today cannot be beat by a human. There's no human being like that woman who's got the highest IQ, that Swedish lady, the Voss lady, who's got an IQ of like 222 or something ridiculous. You couldn't even teach her to beat the chess engines today. You couldn't even teach her. Like, and so if we limited the definition into artificial intelligence as computer mimicking human intelligence, well, then we're constraining artificial intelligence, right? All right, so we have our definitions. So let's go ahead and let me answer what Alex's question, which was, it seems like every maker of software or services says we have AI, quote unquote, really leaning into it as a buzzword. My question and topic of a podcast would be, this is the question, how do I sort through the nonsense to find the true implementations and value versus a company that is just using AI as a buzzword to drive sales? So let's start with this. The vast majority of people who are using AI in their marketing terminology, the vast majority of the organizations who are using AI to market are using it as a buzzword. If you were to ask them, what is your artificial intelligence? They can't tell you. They wouldn't be able to articulate to you what it is. Okay. What it is they know that that's a word that resonates in the market, and therefore they're using it. So number one, go in understanding that most people who are using AI in their marketing don't know whether they have AI or not. Okay, number one. But here are the questions I use. So lots and lots of people reach out, lots of companies reach out, including many artificial intelligence companies. So for example, Sorba.ai reached out to us years ago, wanted me to evaluate their platform. And I'm going to tell you the questions I asked them to determine whether or not they were actually using machine learning and artificial intelligence. These are the questions I asked. So number one, what problem are you solving? Okay, because if you can't say I have artificial intelligence, you can't say that I'm using machine learning if you don't first start with the problem statement. Okay, we don't just build neural networks that aren't designed to solve some problem. We don't just train a machine learning model without first defining the problem we're trying to solve. Okay, so we start with the question, what problem are you solving? Okay, question number two, this is the more important question, how are you solving the problem? Okay,
with AI.
Yeah, with AI. No. Explain to me, walk me through the steps of how you solve the problem. Now, I asked Sorba.ai these questions, okay? And AJ Alexander, who was the guy that I talked to at the time, he's the one who responded. I think he had Aldo, who's one of the partners on there, but I think AJ did most of the talking. And he answered those first two questions sufficiently and in very great detail. Number three, after he told me how he was solving the problem, I asked him specifically how are you using machine learning and or artificial intelligence to solve that problem? Okay, so for example, if I'm using ML, okay, what models are you using? How are you training those models? How are you updating those models? How are you deploying what you trained so that you can monitor real-time data points? How did you define anomalies? How did you define failure? How did you define success? How are you using ML and AI to solve the problem? The moment that the person you're talking to can't answer and or clarify any of those questions, they're full of shit. Okay, and that's a decision tree, by the way. It's a binary. If they can't answer any of those questions, or the moment they stumble or they can't clarify, they're full of shit. The company might not be full of shit, but the person you're talking to is. Okay. One of the questions I like to ask marketing people is, what's the delta between your marketing language and the reality of your product? So I'll ask that one-on-one. I'll say, tell me the difference between the language you're using. Because in marketing, you have to dumb your language down to a 7th grader. So your product might be for only people who have 8 years of postgraduate study, okay, and they've specialized in a very specific field, okay? But you're never going to market your product speaking the language of somebody who has 8 years of postgraduate study. Your marketing language will always target a 7th grader. So you ask them the question, what's the delta between your marketing language and reality? And that was the very first response I had for Alex. But I've thought about it a lot more since then. And so, Alex, I would like to hear from you. What was your response to my response? And is there anything that you wanted to add to it? And then we'll talk about how we're using machine learning and artificial intelligence to give some examples.
Yeah. So, after we kind of had this exchange, I got to thinking about, there is a difference between solving a problem with AI and using AI to solve a problem.
Okay.
So a lot of these companies out there that say, I have AI, yeah, they might be solving AI or they might be using AI to solve a problem, but was it really the right tool? Or was there really value? Maybe they're just using AI in the background to decide what font to throw on their platform, and they can say we have AI, right?
Right.
Like, is it actually worthwhile and worth the investment? Because way too often we run into clients who just say, I want AI, I want ML. What do you want to do with it? And they go, well, I want AI and I want ML. It's like, okay, here's a platform that says they have AI and ML. There you go. Like, we don't want to do that. We want to make sure we're actually providing value with, is AI the right tool to solve the specific problem you're having? You want to use a hammer for a nail, not a screwdriver.
And
right?
give us an example. Given you'd use the ChatGPT example in one of our conversations. Expand on that.
So if I use ChatGPT as an example, I do use chat on a daily basis. It is something that I use to kind of put foundational code together, or maybe help me put some ideas that I'm having together. But there is a certain point where I got to take it. I got to take it from there, because it might be artificial intelligence, but it's not artificial thought, which to me is a really big distinction. That AI tool, at ChatGPT in particular, it's an amalgamation of all of these ideas that other people have had. And it might be putting those ideas together in a unique way, but fundamentally it's still not original. And so, like, as a solutions architect for my clients that have very specific problems, I have to be able to sit there and go, okay, here's this output from chat. Now I need to take that and come up with a solution specific for their problem, because ChatGPT doesn't have my particular thought patterns, my experiences. It's not artificial thought. It's artificial intelligence.
For the sake of this discussion, we are going to define ChatGPT as very close to general artificial intelligence. Okay, we're gonna say that it's close to general artificial intelligence. That it would be the example of artificial intelligence that most people would be familiar with. Okay, and for the sake of machine learning, we'll use facial recognition. If you say you have an iPhone, and you use your iPhone to unlock your phone biometrically, that's an example of machine learning. You're training your phone to recognize your face, and then when you put it up there, it Can it recognize the face? Is the confidence level greater than 99%, or is it 99% or greater? Yes, that's Walker. Unlock the phone. That's machine learning. Artificial intelligence is ChatGPT. That's what we'll say for illustrative purposes for those of you who are not deep in this world. Okay, if we want to illustrate, go ahead, Justin.
And I just want to say something about ChatGPT is it's very easy to forget that it is a language model, not a correctness model.
Yes.
It does not model, and this is one of the hardest problems in the field, is it is very difficult to quantify for a machine what is different between someone who is correct and who sounds correct. So if you give it a bunch of data about things that, perhaps a bunch of, say, correct Stack Overflow answers, but you give it a novel problem, you might just get something that sounds correct. There was one case where a lawyer, of all people, and I'm sure both of you have heard about this, but a lawyer submitted a brief that was written by ChatGPT, and it just...
Yeah, this guy's an idiot.
Wholesale yes, I agree. Wholesale fabrications of previous court cases.
Yeah, they just made the case. ChatGPT just made the cases up.
Yeah. But they sounded like real cases. It was so-and-so versus the state of whatever. They sounded like real cases, and the only way you would know is by having... Oh, I became blurry. Is by having an expert, I was waiting to bring focus back in. I'm not a law expert. Is having an expert, or perhaps just someone who can Google court cases, make sure that your sources are valid. Or in Alex's case, have an expert systems architect, look at the design, look at the code, and say, yeah, this makes sense, or no, this doesn't make sense. And on problems where there's a lot of data, something that looks correct will often be correct, but you still want someone to check it. And this goes back to what I was saying, for example, in the medical field.
So
you have to have that check. You don't want to be over-reliant.
If you look at ChatGPT, just for those of you who don't know how ChatGPT works, I think most people think of ChatGPT as sort of like a person on the other end who's answering your question, except it's a computer. That isn't really what it's doing. What it's doing is it's taking your prompt, it's starting with one word, and then it's trying to predict the next word. So that's all it's really doing. And then that's why ChatGPT responds one word at a time, just very fast. And what it's doing is it's putting the next word, and then it's looking at all the words it put out there, and then it's trying to predict the next word. And then I
think part of that is they slow it down to make you feel like it's thinking.
Yeah. I mean, it's ChatGPT is not giving you a wholesale answer. The way it's doing it is trying to predict what the next word should be,
based on some current state model of the system.
Right, and that's how those LLM offerings just kind of work. Period.
Yep. Yeah.
Right.
But they are not predicting a correct statement, like the correct answer, then turning that into language. They're predicting a reasonable language response. Oftentimes, the common reasonable language response will be a correct answer. Not necessarily. So it's something you have to be vigilant of.
Let's use a couple of examples. So let's talk about some of the examples of us using, let's stay in the machine learning world, and then we'll move over to AI in a second. So let's talk about some of the examples, some of the applications where we have done machine learning use cases. And let's start with, bless you. Let's start with, how do we identify, if you look at what Justin's doing right now, we have, at Intellic Integration, we have some very mature, digitally mature clients, people we've been working with for years. They are, they're 3, 4, 5 years into their digital transformation journey. They have unified namespaces. They're connected, they're collected, they're storing, and they're analyzing, they're visualizing basically every data point, and they have a UNS to do it. And then after that piece, connect, collect, store, analyze, visualize, now it's find patterns, report, and solve, right? So find patterns is where that ML part starts. So we take Justin, we have these clients, and we take Justin, we take other members of our team. So we have another Alex dabbles in ML. We have another engineer who actually is a computer scientist who I think he did his, I think his major
thesis.
His thesis
was master's thesis.
Yeah. Right. So when we go to these clients, and now what we're trying to do is find the use case. where would machine learning be appropriate here? Because the client doesn't say, the client just says, I want ML. By the way, if you put ML in your,
I want ML.
I just want ML. I want artificial intelligence. They don't even know what it means. That's why we're defining what these
and
terms
usually
are.
that's a C-suite thing where they're like, give me AI and ML, and then
Give me
someone
AI
goes,
and
I don't know.
So let's start with one of the first examples of machine learning that we did, which is we used vision to count dough in a tray, right? Let's walk. So Alex, you were part of that. Justin's reviewed that solution, right? So you guys are both. And I know that Evan is the one who led that specific use case, but Alex was leading the project, was the former leader of that project. So how did we identify that as a use case? How did we get started? What were the challenges? How did we make it successful? Because, by the way, it's been very successful. The client loves it. The board of directors, the C-suite has only said now they want to double down on more machine learning, right? But how did we identify that use case? How do we implement? How do we test it? How do we decide it was successful? Where did that come from? And we'll start. And we'll have Alex talk about the strategic components, and Justin, you can chime in on the technical elements.
So with this particular client, they have these these pieces of dough coming down a tray, and they really desperately wanted to know how many there were. And in particular for this process, counting each piece is very difficult mechanically. And so they were kind of racking their brains trying to figure out a way that they could count this stuff. And we were asking all the questions we could, and finally someone said, I think there's a camera pointed at that. And so that was like, okay, cool. Like, give us the recording. Evan took that recording, and with his foundational knowledge of ML, he actually leveraged an LLM, ChatGPT, to ask questions about how to do things. And I think he ended up using the library that you originally did the full strength stuff with. He used that library, and over the weekend, he came up with a way to start counting, and they were getting, like, I don't know, Justin, if you know the actual percentages, but they were getting relatively accurate dough counts.
I think it went from no dough counts to like 80 to 90% accurate.
So 0 to 80, and then I think Justin,
and where is it today? Where is it today, Justin?
I guess that depends on if they've cleaned the camera.
It's a very dirty process.
I think it's still around that 80 to 90 mark. Basically, the one of the issues is you've got these doughs, and they're relatively simple. The problem is some of these little balls of dough will be very malformed. Okay. So handling those is sort of the hard part because they're less frequent, so it's harder to
you don't get
examples to model them.
You classify them in an ideal. You classify them in ideal form.
Yeah.
If you're in non-ideal form, then
it could be harder because some of them sometimes it could like spill over into another dough ball as well, because there's like a bunch of it's like a big muffin tray. Basically.
So the challenge this client had was they really were struggling to accurately calculate yield. So, how much dough are we producing? And without adding in sensors, this was a mechanism, this was a use case where we could just by using machine learning and existing technology they already had the camera. All we had to do was add in a software element and train a model, and that model with 80% accuracy could predict how many balls of dough were in each tray, and now we have a mechanism to calculate yield. That is a very valuable thing to this client. What were the challenges? Obviously, one of them was the camera gets dirty, right? Yeah. That's one. What? Give me some other challenges that they ran into.
I mean, the trays, they come in all goofy, and rolling this particular solution out to more and more sites, each individual line is going to require its own specific training. And so there's, more things, with regards to that for implementing this at a larger scale. But the cost of implementing this thing at a larger scale is way less than the millions of dollars that they would have to spend upgrading all of their equipment to mechanically count stuff. Versus now they just got to buy a bunch of $300 cameras, point them at their line. And yeah, someone's got to take a week and go and figure out how to tune everything. But, the overall cost benefit is, it's pretty drastic.
Why, Alex, why is it we couldn't just use ChatGPT to just write the whole thing for us? So you talk about, we use ChatGPT to basically wireframe a solution for a certain type of problem, right? That's really what you use ChatGPT for. But where did ChatGPT end and where did Evan start? And why is it we couldn't just use ChatGPT and not Evan?
So Evan understands how the dough sits in the tray. Evan understands, how fast the stuff is coming past. He understands that the camera gets dirty. Evan has those thoughts about, what this particular client is looking for exactly. And, he showed me his process of, this was the original code that GPT spit out. And then he took that code and brought it over. And when he shoved it and shoved the camera feed into it initially, it was garbage. It was absolute garbage.
Right.
And then Evan took the knowledge that he has and the thoughts that he has personally. He has his own opinions about how ML should be used and how ML should function, and he was able to apply that knowledge that he has. ChatGPT doesn't, and the thoughts that he has. I mean, he did his thesis with ML, and he was able to take that output that he tried over and over again to get GPT to give him exactly what he needed, and it never did. It never could, because it can't.
So here's I have this thing behind me. It says innovation up on the wall. You can't see it because the camera's down. But innovation, to remind myself, innovation is, the definition is seeing what everyone else has seen, but thinking what no one's thought. ChatGPT never does that. ChatGPT never thinks what no one's thought. It always thinks something someone else thought. Always, 100% of the time. The human being is the innovator. The human being is the one that comes up with a novel concept. The human being is the one who comes up with the idea for the better mousetrap, right? And that's where the ChatGPT ends and the human being begins, in my opinion, right?
And that novel concept, this kind of goes into something that Justin mentioned earlier is, it might seem correct. You might have a novel idea and shove it into an LLM and say, hey, tell me how to do this novel idea. And it's going to spit out something that might seem right. Odds are it's probably not.
Justin, when you looked at Evan's implementation, walk us through how you evaluated its efficacy and what your thoughts were.
So the main, so for evaluating efficacy, the main question is not one of like, so brief. I'm going to do a brief tangent here.
Okay.
Tangent.
Tangent.
There's a couple of things you need to understand when you're evaluating an ML system's efficacy. Oftentimes you'll see papers reporting beating the state of the art on some problem, right? And this is true. They'll get 99.7 instead of 99.6. And that there are some problems where that is like, oh yeah, that's nice, that's good. On a lot of things, it could just be a difference in parameter settings. So the first question is, what's the improvement we're looking for? Well, what we had was nothing. We had no ability to count the dough. We had no ability to understand what was going on.
No yield.
No, we didn't know. We had nothing. We had a 0%. We were at 0%. And we went to 80%. Now, if you divide 80% by 0%, we can see that we actually provided infinite value to the customer. So sometimes you might say, oh, 80%, that's barely passing. No, 80% is huge. This is great.
Yes.
In other contexts, it might be like, yeah, we can, if they already know, like with a 75% accuracy, and we can get them to 80%, but now they have to wipe off a camera lens, it's good, but it's not like insane.
So what do you do with the 80%? If I'm the engineer, what I do is I give them a range. I give them our calculated number, and I give them the range that they can be very confident that yield fell within. Right.
So yeah, that's certainly one option. Is provide them with a range, or you can say, with some problems, and I can't say for sure that it was applicable in this context, you can actually say with a pretty high confidence, oh, and this is more of a statistics thing, is, oh, if I see 80% of the does, then I multiply whatever I find by 1.25, and that's actually a better estimate. This isn't always, don't go blindly doing this sort of thing. But oftentimes you don't need to spot every case of a thing when the goal is just to get an aggregate statistic like a count or a percent that are good. Like when units are being tested on a manufacturing line, in many cases, they're not pulling off every unit, testing it exhaustively. They're pulling off a sample, right? They're pulling, and they use statistics, perform t-tests, choose a p-value well after having. Of course, you have to choose your p-value beforehand, but it doesn't happen as often as it should.
How do you go from 80% to 100%?
So 80% to 100% is hard. Basically, generally speaking,
in this use case, give us
each percent is going to be harder than the last. So the real truth is, from a cost perspective, you're probably better off making some hardware changes than trying to get from 80% to 100% through pure vision analysis. So, for example, one thing you could do is they have, I think it's like a repurposed security camera, basically pointing down at the buttons.
Yeah.
One thing that was discussed as a potential option is using a camera with a depth sensor, because of course our little dough buns poke up from our tray, right? So we can model them much more accurately if we also say, oh, I can sense with my depth camera, which is just a camera that can sense depth, unsurprisingly.
Generally has
three-dimensional.
Generally has three lenses, one in the center, one on the outside. So you might see it called a stereo camera.
Yeah. And you could take that depth as an additional parameter, and suddenly now we're not just having to look and assess visually, we can actually see the topography.
Right.
And that might give us another 10%, get us to 90%, get us to 95%, where the case may be. And then after that, part of it will be improving your training data. How
delighted is the client with 80%?
In this context, pretty delighted.
Yeah. Is that nothing?
And yeah, frankly, it's probably good enough. It can be improved, but it's sort of the question of what is the highest value sort of activity. Is 80% and then some statistics good enough, or do we need like 80% shows it works? This gives you to spend $600 on a stereo camera, on a 3D camera, and then that gets us to 90%. That gets you to spend a lot more money on a data set.
Right. That 80% gives you the data you need to calculate whether or not you should try to get to 100.
Yeah. Right. And oftentimes, for things that aren't either like mission or safety critical,
right,
it's not worth it. Now, obviously, there's some, like in self-driving cars, for example, you need to be, you can't, it's not good enough to be as good as humans, because that's not how people think. They want that car to drive better than they do on the day of their, actually people probably drive pretty bad on the day of their driving test. They want people to drive better than they do with all their kids in the back of their car. So
this is why that level of
you have to be better.
Yeah, that level of accuracy in full self-driving is the reason why you could wear a t-shirt that has a stop sign on it. And if you stood on the side of the road with a t-shirt that has a stop sign on it, any Tesla that's driving with full self-driving is going to stop. Because what it does is it looks for the stop sign. It doesn't look for the stop sign that's exactly 6 feet off the ground and there's no person silhouette around it. What they're looking for is the stop sign. And if they see the stop sign, they stop. It's basically really that simple.
And in some contexts, you also do have to be, unfortunately, this is less common in like assessing your own processes. In some contexts, you do have to be careful of essentially adversarial behavior, right? Because like the stop sign as a prank is fine, but you could use that same principle to cause a car accident.
Oh, absolutely.
And it is only a matter of time till we see something like that happening.
Oh, it's already
at some
happened.
scale.
The only reason I know is because it's happened.
Yeah.
People are pranking. So in Fremont, where they do all the test track stuff. People do that there. They prankers do that kind of shit in Fremont while they're taking the cars out to the test track. So that's how I know that it actually.
Yeah. And,
I was going to say, have you tested that with your car, Walker?
I have not tested it with my car, but what I have tested is a lot of stuff with people. So
he's only hit one of his children.
I have not.
Technically, the car hit his child.
But something happened the other day. So my son, my youngest son,
not a good follow.
So when my middle son graduated from high school, we bought him a new truck. We bought him a Hyundai Santa Cruz, so a brand new 2022 Hyundai Santa Cruz. And that Hyundai Santa Cruz is actually using machine learning for its collision avoidance system. So, and the other thing that car is now my youngest son's car. So my son Jared eventually he bought a Tesla on his own, last year, and then we passed his truck down to his younger brother. And his younger brother and I went to the diner the other day, and he was backing in. He was like, the back of the truck was facing out towards the highway, and he was backing into a parking spot. He was 200 feet from the road. But because the collision avoidance system detected the cars out on the road, it literally slammed the brakes on while he was trying to. There was no risk. It was just that was an anomaly that came from a limitation of the technology. Let's go to use case number 2. So the same client, we've actually done a second ML use case, correct, Justin?
It's in process right now.
All right, let's talk about that use case.
It's actually running right now.
How did we define it? How did we identify the problem? And how did we tie that problem with ML as the solution? And then how did we implement?
So what they have basically in their factory is it's a very large production line with multiple phases, and sometimes the entire line will have to go down for some reason. The problem is they sort of look at it as individual components rather than the whole line, so they're not really tracking when our line is down. And that's obviously a pretty important metric to understand. So, for example, what they said is, okay, can you model when our line is down? And we said, probably. And what we actually have done so far is we had one of our engineers who's sort of familiar with the data and familiar with what their factory floor in the manner in which it operates. Basically generated some labeled data for us. So this is supervised machine learning, which basically means we're giving it data that's been annotated by an expert. And he can generate some small samples of running or not running data and basically say, yeah, here the fact the line was down, here it comes back up, here it goes down, so on and so forth. Then we can use that to train, and this is what we've done and is now currently running and accumulating more data for us, a sort of initial model. And this initial model lets us see, okay, can we generalize from these small data sets? And I don't know yet. It's still going.
Alex, are you familiar with the use case that they're doing? Okay.
Yes.
Why would we choose to use machine learning to determine up and down when the way we generally do that is through status registers coming from PLCs that give us a state register? What is the reason we would use ML in this case as opposed to, because that's the obvious question any engineer is going to go, why would you use machine learning for that? Why not just use a status register and all the assets?
With these particular folks, they have a lot of lines. They all produce roughly the same thing, but every single line is unique. Different pieces of there's an oven in the middle that stays on always. So you can't really use that. If the oven's down, the line's really down, but the line can be down and the oven's still on. there's a lot of different, they're always unplugging and plugging machines back in. There's a lot of like bounce with the different inputs. We have done a lot of work to make it the data that we're collecting as sanitized as possible, because the data that we were collecting initially was just chaos. We had no idea what was going on. It got to a point where for us to definitively say this line is up or this line is down just on the surface was almost impossible without calling someone and saying, is a line running?
Let me say this. This is how fast an organization who does it right. And by the way, and we're going to use a couple other examples. We have about 15 minutes left, but we're gonna talk about a couple of other examples, 2 other examples, I think. But this is an example. This client right here specifically is an example of, if you approach your digital transformation initiative the right way, strategy first, architecture second, minimum technical requirements third. Pick an architecture. It's edge driven, report by exception, lightweight, open architecture. You build a unified namespace infrastructure. The company itself is going to own the infrastructure. They have their own big internal team. In fact, their deployment team is their own team that they've hired since we've been working with them, which I think now is we're going on 3 years in this journey. 43 facilities, right, globally. We're down to the last 46. We're down to the last couple, right? We're down to they're doing the last 5 or so plants right now.
Yeah. We're well along on the rollout.
Right. And the rollout, the rollout approach here is, our work when we deploy a new facility is what, 2 weeks, right? Start to finish. They do some legwork, and then we spend about 2 weeks in each new facility, and we're
2
done.
to 4 weeks, depending, because of that chaos and fine tuning.
But here's the thing. Because of the approach, here's why ML is good for this use case. And this is what I was most impressed with the team with, is the way that you're approaching modeling status, say that you can do uptime and downtime. You could deploy that model across the entire business.
Yep. Every single mixer is different. The exact same model applies because we made it that way.
Right. So it doesn't require engineering at each of the assets, which is going to cost enormous amounts of dollars in engineering.
From a data standpoint, every single asset on the plant floor for all 46 plants is going to look identical.
Right. And we'll end up doing a case study on these guys. But this is an example of how to get it right. And let me say this. This has been a hard road with these guys. This has been no engineer who's worked on this project, Alex included, is going to say this was easy. That no one's going to say, every engineer was pulling their hair out. It was they had very, very aggressive timelines. And they brought in all the major players. They had all, think biggest consulting firms in the world were all there first. General Electric was a big part of this initially. And it was a tough road, but still in 3 years, full organizational digital transformation. And now we're at the ML level, and we're effectively using machine learning to yield value for the business. And we're not spending the capital and then failing and then trying to go get more money so that we could try another use case where the first use case is a success. The second use case is going to be a success. The third use case will be a success, right? And then obviously the piece beyond that is plugging into a digital supply chain, right?
Yeah, I'm very proud of that project, and I use it anecdotally a lot when talking to newer clients about how things can go, if you do stuff the right way.
Do it the right way, right? Let's Justin, so we have give me a couple of other examples that you're looking at right now to use machine learning to yield value for some of our more mature clients. Give me other use cases that you have in mind, and how is it you are making the decision? And the reason I ask this question is this. Most people don't understand where to use ML. To answer Alex's original question, which was, how do you tell whether it's AI, ML? Most clients don't even know to ask those questions to begin with. That's why you need a partner initially to do all of that analysis for you. but most people don't even know where to start with ML. I mean, we've had clients who you hear machine learning and they think, oh, I want it to make all my decisions for me. Use machine learning.
I can just push the machine learning button and it does machine learning things.
And so the reason I asked this question is what we want to really do is kind of educate the end user on where this is working effectively at low cost for high return on investment, right? So give me a couple of other examples here in your first few months. You've only been in industry now for 3 months, right? You were originally
3.5.
You were in health.
My 110-day review is coming up.
I promise you, I'm writing your review. So Matt's had to write it, and I got to write it too. So I promise I'm writing your review. But give me a couple of other examples.
So I would say the overarching idea is look where you have data, and you should have data. If you're a large company, you should have data. And you're not really doing anything with it because it's too complex for a person to analyze trivially. A lot of those patterns are too complex, and there are patterns almost always. A lot of those patterns that are too complex for a person to understand are not too complex for a machine learning model to understand.
By the way, chaos theory says there's always a pattern.
Yes, but it's one of those yes buts. Like, yes, there might be a pattern.
But is it does that pattern mean anything?
And can it be extracted meaningfully? And it could be a case where it's like, let's say I'm trying to predict machine failures, right? And what I don't know is that I've got a saboteur on the plant floor. It doesn't matter how much I look at the variables of the machine when at any time a guy with a wrench can come in and break something.
However, if you're looking at many of those, 100 of those,
we might know that it's weird that it broke.
Yeah, we might know that that's an anomaly. That one out of 100 has a stimulus has been entered into has some intervention
must have been applied to cause unusual behavior.
Correct.
So there will almost always be something there. Sadly, it might not always be the thing you initially hoped for. So that's one of the sort of hard questions is you kind of need to get someone in who understands the context, and you need to put them together with someone who understands machine learning, who understands data science, and say, all right, what's of value and what can we get? Find the intersection of those two circles. It'll never be this. It'll never ever this. It'll usually be something like this. There will be intersection. There will be value to be found. But if someone comes in saying, "Oh yes, I could solve all your problems, tell you everything you want to know," they're lying. Maybe they're naive. They're probably lying.
Let me say this.
It's these platforms that think they have here's your AI or ML easy button.
Yeah, and that's the problem I have. So one of the reasons I'm big on Sorba AI is because they didn't just pass the sniff test, they passed the deep dive. Mm-hmm. Like, there was no question I asked that AJ could not give me a very detailed answer on how it works. And I even got to the point with Sorba where, and this is an unsponsored thing. It's just I'm bringing up Sorba because they're really the only AI, industrial AI platform that I think when they say we're an industrial AI platform, they really are. Like but I am of the belief, okay? I want to go back to the definitions. Artificial intelligence is computers essentially mimicking human intelligence. Okay, we're going to use that definition. And machine learning is using computers to learn from data. Okay, I am of the belief that in industry, your first priority is machine learning. Like, in fact, throw the term artificial intelligence out the window to start. And here's why. Now, purists, data scientists, AI engineers are going to disagree with me. What they're going to say is, well, ML is AI. I get that. Okay. However, for the layperson, for the industrial decision maker, they're not the same thing. They're they apply completely different. Okay. And I'm going to use this example. At fullstrength.ai, we built a vision system, and that vision system, we use machine learning to identify to do pose estimation. We use machine learning to train a model to determine from the pose what they're actually doing. So you got 2 steps in machine learning. We use machine learning to predict to predict force and velocity, distance between the hands. We use machine learning to do all those things. And then we plot those values, what we're predicting, and then we use some machine learning to apply some smoothing. So there's many types of machine learning going on.
The current smoothing is actually closer to AI, but yes.
Okay. but and then we put that on a chart. As an engineer, I have to look at that chart, and I have to tell the athlete what the chart means. So eventually you will use artificial intelligence to do that interpretation. But right now, the human has to look at that data on a chart and say, this is what that means. I'm the one who looks at the lift curve, or someone else looks at it, a coach looks at it. They look at the velocity, they look at the predicted 1 rep max. We're using machine learning en masse to accurately predict what the values are, but we're using humans for the intelligence to analyze. So what I argue is that for most people, ML is the primary focus. Learn from data. That's the primary focus initially. Then we'll focus on artificial intelligence later. Why? Because even though ML is artificial intelligence, okay, it's a subset of AI. The reason why is because the end user doesn't think in those terms. The end user thinks AI tells me what to do. Machine learning tells me what's happening. That's how they think. They think ML's telling me what's happening with a degree of accuracy.
In many contexts, the tells what to do is way, way harder. Because I can, just looking at the data, I can model it, right? It helps, and it's good to understand what this data represents, but those patterns are just there. But translating that expert system in requires the nerd to talk with someone who actually is on the plant floor, understands what to do when they see this data. So you have to hire a nerd that can talk to people, and that's not an easy thing to find.
We have by the way, we have a lot of nerds here who are very good at talking to people. We actually that is one of the differences about our company. And it's just a lot of work, because you need to be able to understand, not only match the patterns to the appropriate feedback, but you need to figure out how to codify and define this appropriate feedback. And that might be saying, hey, this machine's about to break. Or that might be saying, hey, you need to turn this off right now because it's going to cause everything to explode in 10 minutes. But translating that to something that we can interface with the data and not just rely on like a human with a lot of experience and highly developed intuition is difficult. It's really, really difficult. So we have 2 minutes left. So let's do this. I was just thinking about this. I think we should do this again. And what we ought to do is, number one, I want to solicit feedback from the audience. So ideally, what you would do is you would comment in the YouTube chat. So if you're listening to this on Apple Podcast or Spotify Podcast or whatever, or your podcast platform, go if you have a question or a topic you want us to cover specifically around machine learning and artificial intelligence for industry, okay? Go over to the YouTube channel and put the comment in there. What we'll do is we'll probably wait 1 month and we will shoot a follow-up on this very topic, where what we do is we respond to the questions that come from the audience, okay? But I want to part with this. This all started with Alex asking the question, what question should we ask to tell the difference between people who really can solve problems with machine learning and AI and those who are just using it as a marketing term?
Solving valuable problems with AI.
Solving valuable problems. And the answer is this. what we have to do, the real answer is we have to increase the fluency of the average customer so that they even know what ML and AI are. Okay. I believe that the future for our companies, for sure, if you look at what we'll be primarily what we'll be doing over the next 5 years, the vast majority of our efforts are going to shift towards machine learning. So we'll do a lot less of digital transformation and a lot more of ML with mature digital organizations. And many of those are just coming from the organizations we've already transformed. Right. That's where I see that as the single most untapped part of our market. Okay.
But that transformation step is important.
That transformation step
you can't get to AI ML without the transformation step.
Because sometimes the unfortunate answer might be like, hey, there is probably a pattern here, but you aren't collecting all the data that needs to be collected.
We can't start with ML and AI. We got to do all the other stuff first.
The advantage we have is we have control over the infrastructure because that's the way we operate. We operate. You're going to put the infrastructure in that we're recommending, or we're not going to work there. And the reason why is because we know that long term, if we can't solve the problems you're going to ask us to solve unless we have that infrastructure, and that comes through that transformative process. All right.
I want a parting statement real quick.
Go ahead, brother.
If you are in industry and you're not reporting your data, the data you're producing, storage is cheap, backfilling data is hard. If you hire a machine learning engineer 3 years from now, pay him $100,000 a year, and the first thing he tells you is, hey, where's data for me to work with? You better have a backlog of it. You will always want that backlog. Store it now.
Connect, collect, and store as quickly as you possibly can.
Yeah.
Connect, collect, store. Then it's analyze, visualize, and then it's find patterns, report, and solve.
Because backfilling is difficult to impossible and very, very expensive.
And by the way, a year's worth of data isn't enough. 1 year's worth of data isn't enough. We want 24 months minimum. Ideally, you got 5 years. Ideally, you got 5 years of every data point, and then the sky's the limit. Honestly, it really is. All right, Alex, Justin, thank you for joining me, guys. For those of you watching on YouTube, like, subscribe, comment down below. Please put in your questions on what you want to cover again. We will do this in a month. We'll answer all the questions. Thanks for watching, and we'll see you in the next one.
Yep. See you guys.
Take care.